Okay, let's get started. Okay, so let's go. I think we have how many 96 participants. Okay, I think we should have the quorum. Okay, so let's start with the run track of this fall 2021 workshop. And let's start with the lab one. So we'll do two interactive labs, lab one and lab two. Then we'll have a lab three that will be more a demonstration of the T1 offload and that you guys talk about during the first plenary session. And the last section will be the Northeastern Coliseum demonstration. Okay, let's get cracking. We have how many hours in front of us? A few hours. Oops. Okay, I will skip this part. Most of you guys may know me. So we are having currently we are like 4 people for CI and DevOps at OEI now. Okay, let me pass this on the chat window so you guys can get it from anyone. Where is the chat window? Yes, here. Whoop. I pasted the link so you guys can open it on yourself. That will be the lab one tutorial, and you should start by logging on the Podder wireless login at this nice page. Please log on. And why we are logging now? Creating the experience took about 6 minutes when I did it alone, and with all of you in parallel. So I think we will have 85, I think something like active participants on top of the mentors and some people that will just watch what we are doing. It will take certainly a bit longer. So please log on and click on your experiment tab that I show here on my slide. And you should get this view, and you will have to click on this here button, okay? And you will have to select a profile. So the Polar team created a dedicated profile, these 2 labs. There are many of them, and they will showcase them later on. So we have to select this OEI 5G E2E RF SIM. Then we have to finalize. So I put a name on this one, but please leave it empty for you guys. It will be unique, don't worry, okay? Then you click on the next button, and you will have to click on the finish button. Okay, before you click on the finish button, so you will all start simultaneously. So something will be long. So please be patient. Do not refresh your page. That's Kirk advice. Okay, and you will get this page. So are we all of you guys have done this? So the chat. Oh, thank you, Kirk, for the logging. Sorry. Okay, you will have to. Yeah, if you didn't register yet, just finish your registration first before starting the experiment, and you will get there. What I will do, yes, the document with the registration are the MD document I provided. And what I will do is I will share my presentation right away, so you can also get it right away. So let's share the presentation, open, and it should be in the chat. If you are on Linux, sorry, it doesn't work. How can I do that? So normally, you should get my documentation in the chat as an attachment. Okay, 5 minutes. Okay, let me just, okay. Oops. Let me check something. I have not Podder. Yes. Login. Let me log in. Control B, I forgot to log in. No, I already log in. Okay. And normally we should see experiment. Oh yeah, we can start it, all of you guys starting to provision your stuff. So if you have any trouble, guys, use the chat, and if we can answer by chat, we'll support you guys by chat. Or let me just go back to the presentation. So the support model for the lab 1 and 2 will be okay. Reach out on the Zoom chat, explain what is your problem. So if we can answer by chat also. If we need more complex, then reach out to Camille, and she will put you in a breakout room with not myself right now, but later on with myself, Cobus, Kirk, and Laurent. Okay, you will be able to share your screen with the mentor and talk to him. Okay. Please type the test to select which experiment. Okay, let's go back to the screen maybe. Okay, one last second. Oops, oops. So you have to click on the tab experiments. Thank you, Cobus, for the one that could not. You have to this experiment tab. You have a here click button, and then you should select the OAI 5G in end-to-end RF SIM profile. And then you click next and finish. Okay. You should get to a page like this and like this. Okay, I'll start while you guys start all of your experiment. I'll maybe stop at some point to look at the status. Please reach out on the Slack, on the Zoom chat. Okay. So the OAI official GitLab repository is hosted by the Euricom Institute. So it's gitlab.euricom.fr/OAI/OpenAir 5G. And we will use a mirror here. What I mean here is the experiment will be at University of Utah. So this link is available. So we are using this local mirror to lower the stress on the bandwidth and to clone faster. And this mirror is updated every hour at the top of the hour. Okay. Okay. Oops, sorry. How to contribute? Anyone can contribute. You just have to sign a contributor license agreement because the code will belong to the Alliance. All contributions are going through the merge request process. So I've also put a link on the workflow. We are not accepting merge requests from forked repos due to CLA. So that means that you need to be registered on the repo to create a branch and to create a merge request. We are going through a continuous integration build and testing. And next to me, you have Remy, the RAN CI expert. So you can big shout out to him. And peer review. Approval are made during the OAI RAN weekly developer meeting every Thursday, alternating between 11 a.m. and 4 p.m. French time. So Asian or North American people can join later on. I see. I'm lost. I don't see the finish. You have to click next, and it's on the right, bottom right for the select profile. We have two CI Jenkins server. So it's what I call the legacy one and the container-based one. And I did a screenshot of all the RAN pipeline, and it was before Remy added a few ones later this week. And we are planning to have also CI pipeline on the Power platform, such as Powder that we will be using, but also at Colosseum in Northeastern. The repository structure, I mean, you have the common OpenAir 1, 2, 3 for the layer 1, layer 2, layer 3, and FAPI, and that contain all the source code files. CMake targets where you will be building, and all the means of building are located. Okay. Target, you will have some example of configuration file. But on the right, you have what my team, so DevOps and CI, is mainly focused on is CI script, where you have all the bash and Python script used by the CI pipelines, but also configuration files that are used every day by the CI. So they are more likely to be up to date than the one in targets. Okay. We have also some Docker Compose example to deploy. Docker and OpenShift is where we are having the scripting for building images. Doc, you have top level documentation, but also documentation is a little bit spread out next to the source files. I will give you some example later on during the workshop. Oops, did I miss? Yeah, code architecture. I don't have the time to go into details, and in fact, Florian or Dr. Florian Kaltenberger did a nice presentation during our last physical workshop in December 2019 in Beijing. I provided a link, and it's still valid. We will still talk about code architecture, and Panos and Laurent will talk that during the 5G F1 CUD split presentation after the lab one. It's just an explanation on branch and tag naming convention. So the master branch is our release branch, and I am ashamed to be not having updating for a while, but we will do so either before Christmas or right after Christmas. Now that we have a good 5G solution, stable, I would say. Okay. Develop is where CI integration happens once or twice a week. So Remy or Robert are creating integration branch with all the approved merge requests. And we test again and we merge. All other branch are developers' contributions. Once they are merged, they are deleted. Okay. For the tag, we have the V122 example. So that's a tag on master branch when we are doing a ring. So I want to do a 2.00. Year.week are the tag format on the develop branch. And sometimes we are using this _B, or I don't remember having a _C being merged three times a week. Okay. Build enhancement. That's one of the things that we will talk about during the lab one. You are able to select which version of UHD to install. So why we did that is early November in Ubuntu 18, the default UHD driver was changed to 4.1. And for us at OER, we saw that it was not working well in our 5G TDD. So we kept most of our setup in 3.15 or 4.0. So that means that at installation, we are able to select which version of UHD you install from source. Thanks to Laurent, we are able to support now for a few months now, but Ninja to build faster. He did a lot of benchmarking that was very impressive, and most of our CI build are using now Ninja. So maybe at some point we make it the default. Okay. On the roadmap, I would like to have a proper support for Ubuntu 20 and plus. We are stuck at Ubuntu 18. I think it's better to that. Better library approach, especially with the offload, and Laurent will talk about that during the lab 3 presentation. Continuous delivery. Our new CI Jenkins server has a container strategy. That means that we are building image for Ubuntu 18 and Red Hat 8, sorry. And then on our test server, we are not running bare metal, but with containers. So that means that we are rebuilding, and we are copying or having a local registry to propagate this test image to our test server. So the question I put myself is, why not make these images public? So since week 31, I am pushing what we merge on develop on Docker Hub. So I provided the link. So 4 types of images. So InnoDB, ULB, the LTE-UE, and the NRUE. You can retrieve them and play with them without installing a lot of things beside Docker. But your computer requirement shall remain the same as in bare metal. That means that, for example, the AVX2 extension shall be there, or like at least 4 core or 8 core for a G.B with a lot of memory are still required. Okay.
Hey, Raphael, can I interrupt you real quick? It looks like a couple of folks are lost. Can I just do a quick run through of just getting them started, and then you can resume?
I'm done. I think we can switch to help. So let me just stop sharing and let's go to.
Yeah, so I'll just do a quick. Let me turn on my video here. So for folks who got it, it looks like a lot of folks stayed with us, but a couple of folks got lost. So I'm going to do the following. I'm going to paste this URL for the lab one in here. So if you're lost, just follow these steps with me, and we'll try to get you back on track. So if you click on that URL, it'll take you directly to the lab one instructions. And I'm not going to go through everything. I'm just going to kind of try to bootstrap you real quick. So if you scroll down, you should have joined already, right? This is what we asked before. But if you click on this, where it says set up your virtual lab on Powder, the first bullet point there says select this profile. So if you click on that link, it'll take you directly to the profile that you need to select. So if you go there, you can then just say instantiate, so the button on the left, and then you can say next and finish. I'm not going to do that because I don't want to take up unnecessary resources. But if you go through these steps, then that'll start you up as well with the node that you need. So I mean, we can tell. Actually, I can just show you here. I mean, we have a sort of an administrative view, and so we can see lots of folks they have the right profile and their status is ready, which is good. That means you're ready to go. There's a couple of folks that have the wrong profile, right? So if yours says SRS LTE SIM, that's the wrong profile. That's the default profile. It's actually quite out of date, so we should update that. But if you're one of the people that has SRS LTE SIM, then that's the wrong profile. So you can terminate your experiment, or we can terminate it for you. And yeah, try to go through these steps again to select the right profile.
I see Mosen, I see Ganesh, Akimola. Okay, sorry for the name. So guys, you need to terminate your experiment and start again. Sorry.
Okay, Raphael, you can finish up if you went down.
Yeah, I think I have two slides to finish up.
Yeah, sorry about that. I just.
Hey, it's okay, perfect. We said that it was still dynamic, and we will do interactive. So that's the way to do. Can I see? Okay. Okay. So why Lab 1 and Lab 2, in fact, are bare metal is because it's the preferred developer environment. And when you are debugging, recompiling is a must. So when you are retrieving the target image I publish on Docker Hub, they have no meaning of debugging or recompiling. So that's why we do that way. Also, we may create a degraded performance with the container. Okay, let me. Nope. Why we are doing RF simulator? Okay, why not using real radio? So we are 85 or something like that participant today, and we wanted to offer this lab session to a maximum of participants. So at least I don't think you guys have 85 5G radio equipment to run on. So that's why we do that with RF simulator, and they will show what they have while you wait for your experiment to be ready. The interest of accessing, for me, any powder or any power platform, such as Coliseum or in Manhattan, I don't remember the name, is to setting up from scratch a 5G radio is difficult, okay? Even though, even for me and my team at OSA, it's not that easy, okay? So use a prepared environment. It's already nice. You get accustomed to the OAI components. You can switch to your own environment, knowing more of what your requirements are. So you will see, for example, for the 5G RF simulator, one core with a few a file system of 16 gigabytes, and so I don't remember the requirement on the memory. That's enough. But as soon as you start doing traffic and with a real UI, you may require more resources. Okay, and I think that's it for me. I think maybe not. I think I will switch. Yeah, so that's the view that that Cobus showed. I think that now we can switch to your presentation.
Sounds good. All right, so let me share my screen here. So it looks like, and I mean, I have a little presentation I want to run through, but just so you can see, it looks like most folks are ready. So I think we're making good progress here. Yep, if you look at all those, they all say ready. All right, so I'll be quick so that we can get to the actual hands-on part of this. I want to just briefly explain to you a little bit about the Powder platform, which is what we're, oops, that's not what I wanted to do. What we're using for this hands-on session. So we have a paper describing this in excruciating detail. If you're interested, a little bit broader context, Manu mentioned that in the intro already, but we're one of the power testbeds in the United States. The National Science Foundation has funded 4 of these testbeds. We were in the first round, and with Cosmos from the bunch of northeastern universities, and there's Airpo that's focusing on drone communication, and ARA focused on agricultural communication. So 4 testbeds in the power program. So this is sort of our cartoon picture of Powder. And the thing really, big picture that I want you to take away from my introduction here is that what we have here is a very flexible lab as a service environment, right? And this is sort of the way we're trying to present it today as well. So, you know, the goal here today is to focus on OAI as this 5G software environment. And what we're doing is we're giving you a remotely accessible lab that you can go to explore that. Right. So we have city scale. I'll say a little bit what we mean with city scale in a second. We very much have this Lego-based approach, right? So software and hardware building blocks that you can put together as an experiment. We have a sophisticated experimental workflow, which we're going to explain to you guys in a little bit more. We have bring your own device, bring your own software capability, and we've been designated as a FCC innovation zone, which gives us a little bit more flexibility in terms of spectrum use. So quickly here, what we have rooftop nodes and smart street lamps deployed on our campus. We have a private fiber front haul to a near edge compute facility. We connected to a large compute cluster, actually 2 compute clusters. We have a small controlled RF environment. We have a small indoor over-the-air environment. We have devices that we have on buses that go around on campus that give us mobility. We have fixed devices. And then we have devices that you can either carry around or put in your own vehicle for predictable mobility. And this whole infrastructure is software defined end-to-end, right? So it's largely our RAN network is software defined radios, USRPs. We do have some COTS UEs in there as well, as we'll show later. So this is kind of the big picture again. City scale, you know, we're basically on the University of Utah campus. So this is this pinkish area. The snowflakes is where we have our rooftop nodes. This green area is where we have our dense nodes. So these are like smart lampposts, a bunch of nodes. The blue is our fixed endpoints. This shows a map of the shuttles that go around with devices on them. We have a near edge compute here. There's the edge compute cluster and a metro compute cluster. So we have lots of equipment, and all again remotely accessible and composable. So again, for what we're going to do today is to really convey the message that in this environment you can go from simulation, which is what we're going to do for lab 1 and 2, and then, you know, as you gain confidence in what you're doing, or you want to do more sophisticated tests, you go to the controlled RF environment, and then to the indoor over-the-air environment and the outdoor over-the-air environment, right? Of course, you can, you know, jump from 1 to 4, but the point being that this is an environment where you can really, you know, take all these steps in terms of enabling your research. So yeah, like I said, we're going to use the just compute nodes for lab 1 and 2, and we hope to demo the control RF environment and the indoor over-the-air environment if we have enough time for that. Just a quick note, and you know, this is something that you can we'll provide these slides, but you might want to come back to later. This project that you joined, the OAI 2021-4 workshop, we'll keep that active and usable till sometime at the end of the week. If you want to make use of the Powder platform after that, you want to apply for your own project, there's a link there to do that. It's pretty straightforward. You provide a brief description of what you want to do. We look at that and we approve it, or we ask for more information. The project application should be done by, you know, someone senior, like a faculty member or a senior researcher or something like that. And then the students who work with that senior person will join that project, just like you joined the project for the workshop. And then after that, there's a ton of features that we're not going to talk about today. And so we have reasonably good documentation. You really want to take a look at that. Specifically, if you're going to use some of the radio resources, you know, we have a fair amount of those, but not that many. And so you specifically want to know how you can make reservations to do that. Another question that we get asked often is, you know, Powder use is free for academic users. For non-academic users, you can try it out for free, but you know, once you start using it for real, quote unquote, we have a pay-for-use model. So that's my overview. So I'm going to stop sharing and hand over to Dustin for the lab 1 walkthrough.
Thanks, Cobus. Let me see if I can share my screen here. Okay, is that visible to everybody?
Perfect.
Okay, great. So as Cobus mentioned, this hands-on demo or tutorial is going to focus on deploying an end-to-end OAI 5G network. Where first we're going to build the G node B and the NRUE. We'll deploy the network, including the 5G core, using RF simulation mode, and then we'll test it with some end-to-end traffic. And this is all going to happen on a single compute node. So that's what the profile that you've already instantiated uses, is just a single compute node to run this entire thing. So I will switch over to the web page here running the experiment. This is what you all should be seeing, or something similar. You know, a name for your experiment. The experiment state says ready, and it's based on this profile OAI 5G E2E RF SIM that Cobus talked about. You can see that this includes a signal node, and I think most people are there at this point. Looking at the chat really quick. Okay, so if you click on this node, or if you look in the list view, click on this gear, you'll see an option for shell. And so that's the first thing we're going to do is create a shell onto the node in our experiment. And there you have a shell in the single node in the experiment. And we're going to use this for just one purpose, and that is to start up a VNC server so we can access the VNC server through the web browser and do the rest of the hands-on demo. So in order
Dustin,
to do that,
let me just pause you real quick.
Sure.
Folks, there's that URL that I posted earlier has detailed step-by-step instructions for everything that Dustin is doing, right? So it's helpful to follow along as he's doing it, but if you fall behind, it's all written out there in great detail. So if you fall behind, you can just look at that and catch up that way.
Okay, thanks a lot, Kolis. All right, so the command to start this VNC server is share powder run VNC. So you type that into the shell that you've created, press enter, and it will ask you to create a temporary password that you'll then later use to log into this VNC server. So just pick a password that is short and simple that you will remember. It'll ask you if you want to enter a view-only password. Don't do that. Say no. So type in N and enter. It'll spit out some logs, and eventually it'll show you a link to the VNC session. So you can copy that out, create a new tab in your browser or window, paste it in. Give me 1 second here. Okay, so the VNC server does use a self-signed certificate, so your browser will complain. I'm using Safari, and the way to get around this is to click on Show Details, and then there's an option to visit the website. It'll warn me, ask for a password, and then finally I'll get to the web page that is the VNC client. On Chrome, I think the easiest way to get through that self-signed certificate issue is to just, when the warning appears for Chrome, type into, while that browser window is focused, type "this is unsafe," all lowercase and no spaces, and that should jump past this security issue. And then in Firefox, I believe it's something similar to what it looks like in Safari that I just showed you. So once you see this page, you can type in that temporary password that you created a couple minutes ago and press enter. And you should be presented with a VNC session with 4x terminals. I'm going to look back at the chat here really quick and see how people are doing. Okay, it looks like there are a couple people having issues, but they're being triaged. So I'm going to keep moving here in the interest of time. Okay, so once you have these 4 terminals, we're going to use all of these during this hands-on session. So the first thing we're going to do is pick one of the terminals. I'm going to use the top left one here, and we're going to clone the OAI source code. This command is relatively long, so we've provided a couple of helper scripts to enter the commands and show what's being run, and I'm going to use that in this case. And I recommend you do 2 with these longer commands. So you'll find these at local repository bin, and the one that we want to use here is clone OAI. Okay, so it shows us what it's going to do, and as Raphael mentioned, we're using this local mirror. We're cloning a particular tag, and we're doing a shallow clone to reduce clone times and load on the server. So after you see that, you can hit enter, and the repository should get cloned down to your home directory on this node. So if I say ls, I can see that there's the there's the OAI repository. I'm going to just switch to that directory with cd OpenAirInterface. Inside here, we see several subdirectories. Raphael described these briefly earlier, so I won't go on about that. But the first thing we need to do here is say source OAI end. This will set up the build environment. And then we'll switch directories yet again into CMake targets. This is a subdirectory of the OpenAirInterface directory. And in this directory, you'll find the build tool called build_OAI. And we're going to use this to first install some dependencies and then to do the actual build for the GNodeB and the NRUE. So there are some extra notes here in the instructions about building UHD from source and using a particular UHD version, but I'm not going to use those in this case in the interest of time. But please do look at these instructions in full at some point so you can understand where you might want to use that. So the next command we're going to run here is just build OAI -I, which will install these dependencies, and press enter, and that'll spin off that tool to build to acquire and build the dependencies. And this is going to take something like 7 or 8 minutes. So we'll go to the next terminal here and kind of skip ahead a little bit in the instructions to deploy the minimal OAI core network, since we're going to be using that for our end-to-end network deployment. First of all, I should mention that typically you'll want to enable port forwarding. It's not required in this particular case, since we're running all of these all of the components of this network on the same host. But in general, you'll probably be running your 5G core network on a separate host. So to do that, you would type sudo sysctl net.ipv4.conf.all.forwarding equals 1. Let's fix that. Okay, and then sudo IP tables -p forward and accept, with forward and accept in all caps. And this particular image already includes the OAI 5G federated repository, which includes some Docker Compose tools and a script for interacting with those to spin up a core network. So we're going to use that here. I won't talk much more about that since there will be hands-on sessions regarding the core network later in the workshop. So if we switch directories over to opt OAI cn5g fed /Docker Compose, you'll find this this core network script that we're going to be using, and I'll just start that up. Python 3./core network type, and this is going to be start mini for our purposes. We are going to disable FQDN. So FQDN, no. And we're going to use scenario 1. These options will be explained in later sessions, so I'm not gonna belabor those. So this script will use one of those Docker Compose YAML files to spin up a minimal 5G core network, and it'll take a few seconds to do that. Eventually, it will tell us whether or not the core network is happy, and whether or not we can proceed. So we can still see here in the terminal on the upper left that the the dependencies for OAI are.
I think we need to slow down a bit.
Yep, I'm just about to pause here since this is still going to take some time. So, going back to the chat here.
Dustin, maybe if you can show the instructions and just show people on the instructions where you're at, what you've done so far.
Yeah, sure. This is the instructions for lab 1. We started this VNC server and logged into it. I assume most people have managed to do that. It looks like people are having issues with copy and paste. Yeah, so copy and paste into and out of the VNC sessions in the browser is problematic. So we recommend just typing the commands, and we've also provided several helper scripts to type the longer commands for you. We'll be using more of those later. We cloned the repository, but we used this helper script to do that. So that clones down the OAI RAN repository. We then switched into that directory. That'll be in your home directory on the node that exists in your experiment. We set up the OAI build environment, and then we moved to the CMake targets directory. We skipped this little part about building UHD since we're just using RF simulator mode and we're a bit short on time. So you don't necessarily need to do that. And instead of building with the USRP here, I just passed the -I instruction and ignored the UHD driver for USRPs. And so while that build or the install was running, in the interest of time, I skipped forward here to do the minimal Docker core deployment. And at this point, that's where we're at. Go back to my VNC session here. Looks like I lost it. Just log into it again. Okay, so let's see here. Copy and paste. Where can we find the commands? I think, okay, that's been covered.
There's someone who's unable to type into the shell, and I know I've seen that with some browsers, but it looks like that's happening for this person with whatever browsers they've tried.
Oh, yeah.
So.
It looks like it's happening in all three. So this is not an issue that I've experienced. I'm not sure how to.
Make sure that you've clicked into the terminal. And if you're not getting a response, you can try a different browser. If you're having problems with multiple browsers, sorry, I don't know what to tell you. This usually works for most people.
Yeah, Rodolphe says that, yeah, your mouse should be over the terminal that you want to type into. So in these, in the VNC shell, you hover over on the shells will focus the shell that is hovered over. So even if you have previously clicked into a terminal window, if you're hovering over another one, yeah, I think you'll be typing into the wrong terminal.
So let me just quickly say, and someone asked this question already. If you uploaded your SSH keys, you can also SSH into this node. The reason we didn't do that is oftentimes folks have difficulty setting up their SSH environment, and so this run VNC is really not an ideal way of doing it, but and it is a little bit cumbersome, but it's also typically easier to deal with when we do tutorials.
Yeah, and if there are people doing that using the just SSHing into the nodes directly, if they want to see the well, if they want the commands to work that are going to enable the soft scopes that we'll be using to visualize the uplink and downlink transmissions, they'll need to they'll need to enable X forwarding. If you don't want to enable X forwarding, in that case, you just leave the -D off the commands for running the soft modems later. Okay, so I see some people are still having problems, but I'm pretty aware of the time here, and we're running pretty short. I think probably it's in our best interest to press on, and for those of you who are running behind and having issues, you can always we'll be available to answer questions later as well, and you can continue on with the instructions behind the scenes. So okay,
yeah,
so
and maybe just, I mean, you can you can come back and recreate your node and carefully follow the instructions here after the time, right? I mean, this it'll still work. So if you get lost, you can always come back and try it again, as Dustin said.
Okay, with that, I'm going to move on here. So I'll kind of go back and forth between the instructions as I move on here to maybe help people follow along. So we have this the core network up and running, and we're going to run this command sudo docker logs -f OAI AMF in the same terminal that we spun up the core network with. And we'll need to do this with sudo docker logs -f for follow, and then the AMF access management container, and that will spit out this log that's not very interesting at the moment because we don't have a Gnode B running. Let's finish our build for the Gnode B, and you'll see instructions here to do that. I was right before the core network startup instructions. So we'll do that in the same terminal that we installed the dependencies in. So /build OAI. We're going to instruct it to build the Gnode B, the NR UE, and we're going to be using the RF simulator. So we'll say -W capital SIMU. And we also want to build the NR soft modem. So this is a --build-lib NR scope. And then finally this Ninja flag, which speeds up the build a bit. So start that up. So at this point, we've done the build OAI RAN steps, cloning the repository and installing dependencies. Then we're in the process of building. We've deployed the 5G core network, and we're looking at the logs for the AMF in one of the terminals. And now we're just going to be waiting on the Gnode B for a few minutes. So this is a good time for people to catch up. Let's see here. Looking back at the chat here. I think most people have had their questions answered. Yeah, looks like people are having some issues with the with the X terminals, if you've managed to close one, you can always type Xterm into another one of the terminals to open up more terminals. Build script seems to have no --g node B options.
Okay, Dragolash, I think it's a question for me.
Yeah.
Yeah, so the build allow you to build extra libraries. So one of them that we'll use is which one we used. I don't remember the. Let me check back. Go back to the tutorial.
We use the NR scope.
Yeah, the NR scope. Yeah, so NR scope, and in the if you go to the next lab, that is what I call the extension. You will also the Telnet server. So that means that it's additional shared libraries that you can build on demand that are not necessarily needed from the basic GNodeB or eNodeB or NRUE deployment. Is that okay for you, Dragolash? Yes, and was on yeah. If you have too much trouble, I mean, sometimes we will ask you to go to a breakout room, and I was with someone else just before, and as you just said, Xterm and the I don't remember the end commercial end to have multiple Xterm if you closed one of them. So I don't know where you stand. Okay, so you are building the GNodeB and the NRUE. Okay.
Yep, we're just waiting on that build, and I don't expect it to take much longer here.
Yeah.
After that build finishes, we'll start up the GNodeB and the NRUE, and then we'll generate some traffic. It looks like we have a question around what is the minimal core deployment? Do you want to save that for the answer to that for a later session, Raphael, or do you want to
you need to come to the next day presentation, so that's on the core. So on the core, you okay. Who didn't start the build OAI -I? I mean, that's maybe a question that we should ask all of us.
I'm sorry, I missed that. What did you say, Raphael?
Who didn't start the build OAI -I? Put that on the Slack. Who didn't start that one? And if we have no answer, who didn't start the build GNodeB NRUE command? Okay. Okay, so to come back to Vikash discussion, I'm still waiting for Dustin build to be finished so I can answer some questions. So the minimalist core deployment is you just have the minimal required component to do a core, that is the AMF, SMF, and the UPF. And as soon as you start, yeah, thank you, Rohan. Okay, I don't have to copy. Okay, Maddy asked about beneficial library that could be built in addition on NRScope. So the one that we'll do on, if you go the next part of the extension, it's a Telnet server. So it's we are able to instantiate a Telnet server within the soft modems. I don't remember which one. I think it's if you tap build away -build lib and you put nothing, it will give you the help. Will give you the answer.
Yeah, or make all build all.
Oh, okay. Thank you, Laurent, for the help.
Yeah.
Okay, this build is nearly complete. Okay. So once you reach this build should be a successful step.
It's okay. C'est pour ça que de toute façon, le lab 2 à la rigueur.
Sorry, Raphael, did you have something there?
No, it just came in that remind me that we are way behind schedule.
Yeah. Okay, I will speed.
No, it's okay. It's okay. Just let's everybody does.
Okay. Now we have this the modems, the soft modems ready, built with the RF simulator mode and the NR scopes. So if I go back to the instructions here, there's a commands that we can use to start the Gnode B. I'm going to use this helper script again. So I'm going to do that in the same terminal that I'm used to do the build. So local repository bin, and then it's start Gnode B. Okay, so here's the command it's going to run. It's going to say, hey, use this Gnode B as the RF simulator server. Run the NR soft modem, which is the Gnode B, in RF simulator mode and in standalone mode as opposed to non-standalone mode. And then this -D argument will open up the Gnode B soft scope. And finally, we're pointing to a specific configuration. So I'll press enter to start that up, and we'll see some action in the 5G core AMF log. The Gnode B soft scope will pop up without anything meaningful in it, since there's no UE yet. I'm gonna minimize this by right-clicking on it and check out the AMF log, and you can see that we now have this Gnode B called Gnode B-Eurocom-5GNR box connected to the core network using PLMN 20895. And now that we have that, I'm going to use the bottom left terminal to start up the UE, and once again use a helper script for that. Local repository bin start NR UE. It's going to act in RF simulator mode and connect to essentially the local host, which is where the Gnode B is running the simulator. It's going to run the NR UE soft modem with the number of resource blocks being 106, the numerology being 1, so 30 kilohertz subcarrier spacing. This ends up being 40 megahertz bandwidth. We're going to be using band 78 and this center frequency. And once again, RF simulator mode, standalone mode, and we won't use a kernel module for the tune interface that the UE will create to pass traffic around. We'll start up the UE soft scope, and we're using this particular UE configuration, which sets credentials that match the minimal core network deployment. So press enter. Okay, we have the UE soft scope, and immediately we'll see action in the all of the terminals. We'll note that you can see in the core network that the PDU session has been set up. You'll see in a moment that the UE is registered. So here it is. This is the IMSI of our soft UE. And if you look at the log output for the Gnode B, you'll see information about the downlink and uplink shared channel heart processes. And you can look at the scope and see some channel metrics that I'll leave. The description for these will be discussed in another hands-on session, so I'll leave that for now. But just to show you that we have constellation diagrams for the downlink shared channel, the broadcast channel, and channel impulse response measurements, things like that. So I'll hide that away, and then we'll just generate some traffic really quick. We're just going to use ping to do this, but we're going to use a specific interface which the soft UE sets up. It's this OAI tune _ UE1 interface, and we can see it picked up this particular IP address. And in the core network, there is a container that is an external data network that's there specifically for the purpose of receiving and or generating traffic. So we're going to ping that particular container using this OAI tune UE1 interface, and the IP address for that external data network container is 192.168.70.135. So if we start this ping process up, we'll see traffic moving around. We'll also see that the uplink shared round numbers and byte scheduled are ticking a little bit faster at the G node B, and we see round trip travel times for the ICMPs on the order of 100 milliseconds. And just to prove that this is passing through the RAN, we can ping that container directly without using the interface that the soft UE created, and we'll see that round trip times are significantly lower. So that is the end of this hands-on session. Hopefully, the majority of people were able to follow along. Again, you can always go back and restart this experiment later in the day if you weren't able to get through all the instructions, and go through these instructions again in detail, and feel free to reach out to folks at Powder or at Eurocom with questions. Thank you.
So given where we're at time-wise, I'm assuming, Raphael, we're going to have to cut short this session so you guys can do lab 2.
Yeah, it's okay. I mean, I think anyway, first we have a presentation from Panos on the 5G F1 CUDU split. So
Okay.
people that are late can still ask questions on the Slack, and yeah. So one last thing is no core question. Sorry, there is a core session tomorrow. So here we are focusing on the RAN. Okay, that's the RAN track today. So so sorry about that. It's okay. So I think I will let's switch to Panos doing the presentation.
Can I take a minute just to kind of say what we were planning to do and what we can do as sort of a backup, as it were. So I want to go just quickly back. You know, one of the points we wanted to make was to say, well, you can go from simulation to control RF. You know, you can do all this stuff, and so in order to do that, you basically will be modifying the profile, right? And so what we had and we'll post these slides for you. We had more details on what a profile looks like, and I'm just gonna, you know, if you click on on your profile and you view source, you'll see it's just a Python script, right? And this is about as simple as they come. This is the one that you guys executed. And what we were planning to do is to show how you can extend this profile script to set up your lab a little bit more complex, right? If you wanted to do use real radios. So that's you know, and we'll have it pointed to the slide so you can look at that. And then the other thing was we had demos for you know, both a workbench setup and actually, let me just scroll down here for, you know, what we call paired radio and indoor over the air. And we will just point you all to videos where we have demos of these that were recorded. So that way, you know, you can still get the sense of going from simulation all the way to over the air. And basically you do that by changing your profile, you know, so setting up your lab in a different way, and then you still compile OAI in much the same way. Of course, at that point, rather than doing simulation, you will specify SDR. So that is sort of in a couple of seconds. That was the rest of the session that we didn't get to.